Report.
All right. How is everyone? Hope everyone is doing well. Um, Today is day 3 of 7 of the data analysis workshop. Okay. So before I begin with the recap of day 1 and day 2, let me first see if people can hear me. If you can hear me, please type in a Y. If you can hear me, please type in a Y. Okay, that's 3. Okay, 4. Okay. All right. Looks like people can hear me. Excellent. 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 Um, so let me just type this in. If you can hear me, type in a Y. If not, type in an N. If you can, okay, great. All right. All right. So we're going to go through a brief recap of days 1 and day 2. Okay. So this is our data analysis workbook that we're using to guide us through all of the steps of the data analysis process. Okay. So there are 4 phases: statistical test selection, data preparation, preliminary analysis, and primary analysis. Day 1, we did statistical test selection. Okay. Day 2, we started data preparation. We will continue with data preparation today, which is day 3. All right. So let's cover what we did in day 1. All right. That was statistical test selection. All right. So essentially, we have 3 research questions. Is age related to optimism, life satisfaction, perceived stress, and mastery? Okay. Are optimism and self-mastery predictors of perceived stress? Is there a difference in optimism among young, middle-aged, and older participants? So the first thing we had to do was to determine what kind of research question we were working with. Was it a relationship question or was it a difference question? Okay. And the terminology or the definition of the question types is on this page. And we came to the conclusion that research question 1 was a relationship question because it has the word related. Research question 2 was also a relationship prediction question because it had the word predictor. And then research question 3 was a difference question because it had the word difference. Is there a difference in optimism? Okay. All right. Then the second step was to write the null hypothesis for each research question. And the null hypothesis is simply that there is no effect, whether there is no predictive effect, there was no relationship, or there's no significant difference. So we came up with these 3 null hypotheses. Okay. So age is not significantly related to optimism, life satisfaction, perceived stress. Optimism and self-mastery, research question 2, are not significant predictors of perceived stress. There is no significant difference in optimism among younger, middle-aged, and older participants. So that was step 2 on day 1. And then step 3 on day 1 was to identify the independent and dependent variables. And we said that anytime we have a relationship question, the assumption is that there is a bidirectional relationship. So there is no variable that is being influenced. It is a mutual influence. So all of the variables are independent. Okay. Now with prediction, it's different because with prediction, the assumption is that one variable or multiple variables are affecting another variable, right? So then you would have an independent, which is optimism and self-mastery, are affecting perceived stress. And then for research question 3, the independent variable was age group, right? Because the notion was that age group was affecting optimism scores. The particular age group you belong to is going to have an effect on the variation in optimism scores. Okay? Now, and then in step 4, what we did is we had to define the levels of measurement of each of the variables. So we talked about categorical variables, which are either nominal or ordinal. And then we had continuous variables that were either interval or ratio. Okay. Again, there are pre-workshop videos that go into details about these levels of measurement. Okay. So that is, I didn't go into a lot of detail, but suffice to say, we came up with age as continuous as a ratio variable because any variable that is ratio has an absolute 0, where 0 is the absence of the phenomena or characteristic. Scales are that have 4 or more categories or scoring components, you know, are always interval. Okay. They're interval because they're not ratio, because 0 has no meaning. Okay. Optimism was an interval scale. Life satisfaction scale was interval. Mastery was also interval. And then research question 2, again, optimism and mastery were interval. Perceived stress scale was interval. Age group was categorical. It was ordinal, right? Because you had 18 to 29 was 1, 30 to 44 was 2, and 44 plus was labeled 3. So the numbers went in a particular order. They were ascending age groups, okay? And then we had optimism scale, which was interval, all right? And then after that, we went through the process of elimination, right? We looked at the characteristics of the research questions, and we looked at the different research, the statistical tests. We had differences test, and then we had relationship test. So we went through and we said, okay, what are the characteristics of this test? Do they fit the research question? What are the characteristics of this test? And we did process of elimination, okay? And then we came out with the bivariate correlation for research question 1, and then to address research question 2, we came up with the multiple regression. And then with research question 3, we came up with the one-way ANOVA. Okay. All right. So that was day 1. Now, on day 2, we started out with data preparation. And essentially what we did is we said, hey, let's look at the variables that have missing values. Okay. Missing values. So what we did is we ran descriptive statistics. And then what we did is we said, okay, which variable has the most missing that is not a conditional question? And remember, a conditional question is a question that only some people get, right? And that conditional question, if you remember, was smoke, right? Do you smoke? If you said no, then you did not get the conditional question, which was smoke number of cigarettes smoked. Because if you don't smoke, then we're not going to ask you how many cigarettes you smoke, right? So someone asked, okay, well, why don't we just put 0 for the people who don't smoke? Well, the reason why we don't do that is because it distorts the average, right? We want to know the average number of people, the average number of cigarettes that smokers smoke. If we add in all the zeros for the non-smokers, it distorts the number because we have it biases the number because we have all these people who don't smoke. We're looking for the average cigarette smoke of the people who smoke. So if we add in all these zeros for people who don't smoke, it's going to lower the average. If that makes sense, type in a 1. If that does not make sense, type in a 0. Right? Because if I'm saying, hey, what is the average number of cigarettes that smokers smoke? And then we add in all these zeros with people who don't smoke, that's going to lower the average. We don't care what the average of the people who don't smoke, because it's always going to be 0. If you can hear me, type in, oh, I did that. All right. Okay, great. All right, excellent. All right. So what we're going to do is we're going to start, we're going to go where we left off. So for round 1, we saw that cigarette smokes per week, 79 people did not get that question because they didn't smoke. So our action taken is we didn't do anything because it's a conditional question, therefore not included in missing value analysis. So then we went to the next highest, which was source of stress. Source of stress had 17 respondents who did not answer that question. So what we did legitimately is we went back to the original source. We looked at the ID numbers for each of those 17 people, and we tried to see if there was some kind of mistake, the number didn't get transferred over, so on and so forth, right? So we found out, basically, hypothetically, that these were all missing, and we deleted them. So then after we deleted them, we went to round 2. We ran the frequencies again, and then we found that perceived stress, there were 5 people who did not answer the 10 questions on perceived stress. We had seen that maybe, I guess they got fatigued or something, and they just skipped all 10 questions. So again, we go back to the original, look to see if the data is truly missing. We assumed that it was, and then we removed those 5 missing cases. Then in round 3, we saw that there were 2 respondents who did not answer the smoke question. In other words, are you a smoker? Yes or no. 2 people didn't. We went back. Let me see what we did. Let's just open the file. Okay. And let me open the syntax. Now, remember, we used the syntax, right? Remember that? Because the syntax is a written record of everything we've done. And the beauty of syntax is simply this. So let's say that you did something wrong with the data, right? Because we saved the data file as a work data file, right? Because we never want to damage the integrity of the original data file. So what we did is we saved the work data file as the name of the data, and then we underscore it and just type work, because we're going to be working with that file. That's why we call it a work file. Okay. Now, so let's say we made an error and we had to start all over. Well, if you have the syntax, all you got to do is just highlight everything and just run it, and it'll take you right back to where you were, like that, instead of having to go and click, 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 right? And then we can go and we can see exactly what we did. Round 1, right? Round 1, we did this. Select the respondents, removed. Round 2, we ran the descriptives, select the respondents, and then we filtered, right? Because we always want to test the selection first before we delete anything. Run the descriptives, test the selection, delete. Run the descriptives, test the selection, delete. Okay? So let me see what we did here. So now we're on round 3. Let me see if we actually looked at, if we actually did smoke. I think we did, but I just didn't type it in. So let me highlight this, round 3. And then, so what we do is we come here and let's see, We look at the missing, let's see, there's 172. We're not counting that, remember, because smoked per week is not, it is a conditional question. Okay, so everything looks good. So now we only have one missing. And remember, the reason why we're removing these responders that have missing data is because whenever we run our analysis, we want everyone to have the same N. Because if some people have missing data here and some people have missing data over here, when you run your statistical test, your N's may be different, and you don't want that. You want the N's to be the same for each of your tests. You want everyone to be involved in all the tests. All right. So it looks like child is the only one that has anything that's missing. Okay. So then we go back to our data file and we go to child, right? And then remember, we're going to sort ascending so that we have the missing. So what I did is I right-clicked and then I clicked sort ascending so that we always want the missing values for the variable we're looking at to be at the top, because then we can see if we're selecting it properly. Okay. If that makes sense, type in a Y. If that makes sense, type in a Y. If it does not make sense, type in an N, because if we don't move the missing values to the top, then they're going to be dispersed all over the place. And we got to scroll down and see, is it selected or is it not selected? Okay. All right, great. So, all right, so let me see. So let me go back here and I'm going to say for smoker, removed 2 missing cases from smoker. Okay, so now we're in round 4. So we're going to go to our syntax. Okay, and we're just going to highlight this because we're always running the same frequencies. We're going to call this round 4. And then we notice here that child is the one that is missing. So what did we do? Now, you can run, if you notice here on the syntax window, they have the same menus. So you can run data select cases from the syntax window. You can run data select cases from the data file menu, or you can run it from the output menu. They all have the same menu. Okay. Okay. They all have the same menu. So it doesn't matter where you run it. So we're just going to do data select cases, and then we're going to go if condition, and then we're going to say missing, right? Just like we did before. Go down to missing. And then we're going to put child here. But what we want to do is we want to put this ampersand, because ampersand means not, okay? So in other words, we want to select cases if there is no missing child case, okay? So select means we want to select for analysis, right? So that means it's going to cross out the one that's missing, right? Because here's the thing. If we didn't have this ampersand, right, and we just ran it, here's what would happen. It would cross out all of the cases except the missing one. So when we say select cases, we want to select the cases for our analysis. So we have to put in the ampersand, which says not missing, right? So we click not missing, and then we click paste. Go to our syntax. not missing data for child. Okay, so do you see why we have to put in the ampersand? If you understand why we have to put in the little ampersand, if this makes sense, see now what it's done, it says, okay, we want to select the ones that are not missing for analysis. So when you see select cases, think of it as select the cases for analysis. Think of it that way. So we're selecting the cases for analysis. That's why we had to do this. If that makes sense, type in A1, okay? Essentially what we're saying here is select the cases that do not have a missing value for child. That's what that little squiggly line means. It means is not missing the child case, okay? All right. Okay. Because if we took that out, we are telling it select the cases that are missing. We don't want to select the cases that are missing for the analysis because they're blank. All right. So then we go to the syntax, highlight it, and boom, it's selected. So now what we do is we go back, and now we're going to delete it. So we keep everything and we're going to delete it, and we're going to click paste. Okay. And then we're going to say remove. It's so much quicker. Values for child. All right. So basically what we're saying here is we've highlighted, we've excluded the missing value for child. Now we're going to delete the missing value for child. That's what this means. So when I run this, look what's going to happen to child over here, right? This is the one that's missing. So when I run this, it disappears. It's taken out. Okay. All right. And then we're going to save that. And then we're going to go and run it one more time just to make sure. So this is round 5. So I always like to start with a brand new clean table. So I go to the top, I highlight it, and then I click delete, okay? And then I open up the syntax, highlight and run it, go to the very top, and we have no missing values, okay? Except for the conditional, which is fine, all right? So now we can go back here. And we just leave, let's see, a note to ourselves. No missing values except the conditional question. Smoke, no. All right. So this one was child, and it had 2 smoker. Oh no, child was missing 1. Oh, did I save it? Oh, I deleted it. Let's see if I can go back. Yeah, child had 1, 4, 14. Okay, great. 1, 4, 14. Removed 1 missing case from child. Okay. All right. So now we have finished with checking for missing values, right? So now what we're going to do is we're going to what we call recode. Okay. We're going to recode the variables. Okay. Well, no, before we do that, we're going to make sure. So after we delete the missing cases, we're going to check the numbers to make sure there are no errors. Okay? We're going to check the numbers to make sure there are no errors. All right. So males, females. Okay, so this is valid. Age, this looks fine. 82. Okay. Single, steady, relationship, widowed. Okay, these look fine. Yes, no. So what we're looking for is we're looking for responses that don't make sense for the variable. All right. Highest education completed. All right, these look good. This looks good. Smoker, yes, no. Cigarette smoked per week. Okay, so these are the people who smoked. And we had 72. So there were some who, okay, so this is a good point. There were some people who smoke cigarettes who don't smoke every week. But if you add the people who don't smoke at all, it's going to distort the numbers. So that's why we don't include them. All right, so optimism scale 1 to 5, 1 to 5. Let's look at our questionnaire, right? We have to look at our questionnaire. So optimism scale 1 to 5 is strongly agree. So that's a valid scale, okay? All right. So 1 to 5, optimism 1 to 5, 1 to 5. So if we were to see something like 1 to 6, then we would know that 6 is an error. Okay. If that makes sense, type in a Y. What we're looking for is values that don't align with what the scale says or the data or the variable should be. All right. So 1 to 5, 1 to 5. Okay. So mastery is 1 to 4, right? Strongly disagree to 4 strongly agree. So anything between 1 and 4 is good. Uh-oh, we got a problem here. There's a mastery score that is 5. Okay? There's a mastery score that is 5. That is what we would call a data error. Okay? Now, when you have a data error, what you have to do is you have to go back to the original source. So here's what we would do. We would go to our data file and we go to mastery. Okay, let's see, mastery. It was mastery Q2, question 2 on the mastery scale. So we go to mastery Q2 and we would say descending because we want the higher number on the top, right? Because it's a 5. So we want the numbers to descend as they go down. So we've got 5 here. So what we would do is say, okay, we go over and we go to respondent 256 in our questionnaire. Okay. And then what would happen is we would go to questionnaire 256 and then we look up the response for mastery Q2. Okay. And then we would say, okay, what is the number that they put in? Well, if it was a 4, then we would replace the 4 with a 5. However, if it was a 5, 5 is an invalid number, right? It's invalid. So if someone puts in an invalid number, you can't use them, right? It's an invalid number. So now this becomes a missing value for that respondent, right? So what we're going to have to do is we're going to have to go back here and say mastery Q2 Number missing. Okay, so, and we say error, number of data errors. There was one, and then we say respondent. Let's see. So there was one. It should have been the person had a 5. Okay. So essentially, what we're going to do is we're going to remove respondent 256. Because normally what we would do is say, hey, this is not a valid number, so we have to delete it. So now we've got a person who has a missing value. So, right. So now we don't want any missing values. So we're going to have to delete them or exclude them from the analysis, right? So we go here. Does that make sense? Do you understand why I have to delete them? They had an invalid data point, and now we had to delete that data point because we went back to the original source, and the original source was 5. They put in an invalid data point. We can't use that. So we delete it. But now we have a respondent 256 who has missing data, and we don't want anyone with missing data. So remove respondent 256 because they had a 5 for mastery Q2. All right. And all we have to do, we don't have to do anything special here. We can just highlight this and just click delete. Oop, they're gone. Okay. And then we can just run this again just to make sure. Yeah. So there are no missing. All right. So what I did as a shortcut, let me just show you. All I did is highlight it, and I clicked the delete key on my computer. You have to highlight the entire row by clicking it here, and I just deleted them because there was only one. All right. So that's just a really quick way to do it. All right. Does anyone have any questions at this point? If you have a question, type in a Q. If you don't have a question, type in a 0. Okay. All right. Why delete the whole row? Oh, okay. Okay, here's the thing. Whenever you are deleting, okay, so that's a good question. Can we delete it if we have more than one case? No. If you have more than one case that you have to delete, then you have to go through and do the data, select cases, and then you would put in mastery Q, right? Mastery Q2, right? And then, so if you had multiple people who had missing values for mastery Q2, then you would go through this process. Because this process is deleting the whole row anyway. That's what the select cases is doing. Because remember, each row is a respondent. Okay? So 256 is a person. 256 is a person. 9 is a person. 338 is a person. 315 is a person. 286 is a person. So when we say a case, we're talking about a specific person. Okay? Can we delete if we have more than one case? When you say more than one case, you mean more than one case missing inside of that particular question? Unmute yourself. Unmute yourself. Yeah, no. You have to go through this process. You have to go through the select cases process because it's more efficient. I probably shouldn't have showed you the shortcut. I should have probably. So, you know, that's what happens sometimes. You know, I've been doing this for 30 years, so I know all these shortcuts, right? But yeah, go through the same process all the time. But I was just trying to save time, but you just go through the same process all the time. But that's a good question, though. That's a good, very good question. Instead of deleting the person, if you just delete the invalid question. Well, here's the thing. You got a problem. Here's the problem. So if I delete the question, I already did. I deleted the invalid question, but guess what? If I do it like that, we still have a value. And that person is going to have a lower representation throughout the entire study, right? Because you don't like to have missing values with respondents. You want everyone to have complete data. And now 256
is in the car. Is that chewing in the pantry? No.
So, right. So you don't want respondents with missing data. We should put in select cases, not missing, but greater than 2 for mastery Q. Right. So here's it, right. So let me do it this way. So let's go back, right? So we say, okay, so we've got this 5 here. So if we were going to do it the traditional way, you're right, Elvira. So here's how you would do it. So we would go here and we would say, okay, we've got this person who's 5. So then we would go to data, select cases, right? And then we would say, we wouldn't do missing. What we would do is we say, select if cases, if mask Q2 is less than 5, right? Because 5 is invalid, right? You see that? 5 is invalid. So we say mask 2 is less than 5. So basically we're telling SPSS, select all the cases in the analysis that are less than 5. Click continue, put on the filter, or greater than 4. Yeah, you can say that. Yeah, less than 5 or greater than 4. Yes, that is correct. You can do either one. That's right. That's right. Greater than 4. You're right. So either way. So it could be less than 5 or it could be greater than 4. Let me do it that way as well. That is correct. Both ways are correct. Greater than 4. That is correct. And you'd probably do it that way because 4 is the max. So that's probably the way you would do it. Okay. Both ways are correct, but your logic is spot on. Your logic is spot on. Okay. Is everyone following me? So let me go back. We had a respondent who had an invalid data point. Okay. We looked here. Under mastery. And mastery has valid scores from 1 to 4. The scale goes from 1 to 4. We saw that here. It's a 1 to 4 scale. There's 7 questions and they're 1 to 4. Somebody put in a 5. That's invalid. So that we went back to the source to see if we could find the right number. And we found out, hey, they just put in the wrong number. So we can't include that in our analysis. So we have to remove it. So what we do is we say data, select cases. For mastery question 2, select cases, select all cases for analysis that are less than 5. right? And then we got that. Let me see, go back to the data file. So then we highlight this. That are greater than 5. Let me do it the other way. So it's greater than 4. All right. So we're saying select all cases that are greater, or you could say are not greater than 4, right? So that's okay. So right. So you could say select cases that are not greater than 4. Right. So that would be the ampersand right there. So you could do it that way, not greater than 4, right? And that would give you right? That would give you the answer because it's not greater than 4. Or we could do, let me take that off. We could do it the other way and say where mass is less than 5. And it gives you the same answer. Okay? Gives you the same answer. Is everyone with me? Do you see how we did that? There were 2 ways that we removed the bad data. If you understand what I just did, where we had to remove the bad data, type in a Y. If it's clear, type in a Y. If you have any questions, type in a Q. If it's not clear, type in an N. Okay. Okay. All right. All right. So let's go through this and see if there are any more bad or data errors. So mastery 4, 1 to 4, 1 to 4, 1 to 4. All right, so life satisfaction looks like it's a 1 to 7 scale. And we look at our questionnaire or our code book, and we have it's 1 to 7. Okay, 1 to 7, 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 1. Perceived stress. Okay, so then we go to perceived stress, and that's 1 to 5, 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 1 to 5. Okay, great. All right, so there was only 1 data error in our analysis. Now, if we look in our code book, it says that we have to reverse code. We have some coding that we need to do. So we've got to reverse code. So there's 6 optimism scale questions. We have to reverse code optimism 2, 4, and 6. Okay, so we have to reverse code. And so optimism is 1 to 5, right? So essentially what we would do is come down here. And so we write here, okay, optimism 2, 4, and 6 need to be recoded. All right. So then we come and we say mastery 1, 3, 4, 6, and 7 need to be reverse coded. And I'm going to show you what that means. So mastery 1, 3, 4, 6, and 7 need to be reverse coded. Okay. And then let's see. All items Okay, we need to compute a composite. Okay, that's fine. So we're just going to worry about the reverse codes first. So perceived stress 4, 5, 7, and 8 have to be reverse coded. Okay, so perceived stress 4, 5, 7, and 8. So this is what we call data transformations or recodes, right? So for optimism, we see here that optimism goes from 1 to 5. Okay, so optimism original codes is 1, 2, 3, 4, and 5. These have to be reverse coded, right? So that means 1 becomes a 5, 2 becomes a 4, 3 stays as a 3, 4 becomes a 2, and 5 becomes a 1. Okay? That's what happens when you reverse code a question. When you have a survey instrument and it says you need to reverse code questions, basically you're just going to flip them. So if somebody got a 1, they're going to get a 5. If someone got a 2, they're going to get a 4. If someone got a 3, they're going to keep a 3. If someone received a 4 or scored a 4, they're going to get a 2. If someone gets a 5, they're going to get a 1, right? You're just flipping the scores, all right? If that makes sense, type in a 1. If it doesn't make sense, type in a 0. All right. Same thing here. So mastery, let's see. Mastery is a 1 to 4 scale. Okay. So you've got 1, 2, 3, and 4, right? So a 1 becomes a 4, a 2 becomes a 3, a 3 becomes a 2, and a 4 becomes a 1. Okay? So 4 becomes a 1, 3 becomes a 2, 2 becomes a 3, 1 becomes a 4. If that makes sense, because we're just flipping the scores, if that makes sense, type in a Y. If it doesn't make sense, type in an N. Okay, great. Great. Anytime you have a question about something, just type in a Q and I'll come to you. All right. So then let's see, what's the other one? Perceived stress, PSS, I believe that's 1 to 5. So that's 1 to 5. So this is going to be 1 to 5 as well. So then a 1 becomes a 5, a 2 becomes a 4, a 3 becomes a 3, a 4 becomes a 2, and a 5 becomes a 1. All right. All right. So now here is how we do this in SPSS. All right. So where's my data file? Okay. Oh, I need to clean that up. I'm just going to delete this. All right, that's fine. And I'm just going to write the notes. Remember, anything with an asterisk is a note. Mastery. Question 2. Less than 5. Oops, no. Okay. All right. So we did that. So now what we're going to do is we're going to do the reverse codes. So the first one we're going to do, and we have to do them one at a time. So we're going to start with optimism. So we're going to go to data. I'm sorry, recode into different variable. Very important. You never want to damage the original variable's coding. You always want to create a new variable. Okay. So what we're going to do is we're going to, let's see, it says 2, 4, and 6. So optimism 2, 4, and 6. So optimism 2, optimism question 4, and optimism question 6. So then what we do is we're going to, it says, give it a name, a new name, because we're coding it to a different variable. So what we're going to do is we're going to call it OP2 underscore REV. That tells us that this new variable has been reverse coded. Okay. Then we go to the number, the next one, OP4 underscore REV. That means reverse code. OP6 underscore REV. That means reverse code. Now, all 3 of these are going to have the same reverse codes. So we're going to say old values. If it's a 1, it's going to be, let me see, let's just make sure. If it's a 1, it's going to be a 5. So if it's the original is a 1, the next one's going to be a 5. If the value in the original is going to be a 2, the value in the new one is going to be a 4. If it's a 3, it's going to be a 3. If it's a 4, it's going to be a 2. And if it's a 5 in the original, it's going to be a 1 in the new one, in the reverse code. Okay? If that makes sense, type in a 1. If what I did makes sense, type in a 1. If it doesn't make sense, type in a 0. Okay? Now, we're going to click continue, and then we're going to click paste. Because, again, this is our syntax. So now what we're going to do is we're going to say recode optimism Q2, 4, and 6. 1, 2, 3, 4, 5, 2, 5, 4, 3, 2, 1. Okay. All right. So now we're going to highlight this and we're going to run it. Okay. Now, you will notice on here it says accuracy confirmed. Okay. Here is how we are going to confirm the accuracy. And you always want to do this. We're going to run a crosstab on the original and the new one. So we're going to go to analyze, descriptives, and then we're going to say crosstab. So opt2 by opt2 reverse. Then we're going to click paste. We don't have to do anything else. And we're going to call this recode check number 1. So we highlight this and we run it. So what this tells us is this is the original. This is the new one. So for the original, anyone who scored a 1, they are now scored a 5. Okay, in the new file, in the reverse code. This is where, let me just get my pen here. Where's my pen? Okay, there we go. All right. Oops. So we've got 1 and 5. And then we've got here, right? And then we've got 2 and 4, and we've got numbers here. And then we've got 3 and 3. This is where the numbers are. We've got 4 in the original and 2 in the reverse code. And here's where the numbers are, the number of respondents. And then we've got 5 and 1, and this is where the numbers are. If this makes sense, type in a Y. If it doesn't make sense, type in an N. Okay. And what we're trying to do here is we're just trying to line these up. Okay. So if they got a 1 in the new file, we're seeing that these people who got a 1 in the new file have a 5 in the old file. If they got a 2 in the new file or the new variable, then they got a 4 in the old one. If they got a 3 in the new variable, then they got a 3 in the old variable. If they got a 4, then they got a 2 and a 5 and a 1. All right. So we're going to check for each one. All right. So then we go back and we're going to say confirmed or yes. Yes. Okay. So then we're going to go to mastery. So let me see, mastery 1, 3, 4, 6, 7. So mastery, recode into different variable. We're going to reset 1, 2, 4, 1, 3, 4, 6, 7. Oh, I'm looking at the wrong one. Mastery 1, 3, 4, 6, 7. Okay. And then we're going to call this MAST 1 reverse code. MAST 3 underscore reverse code. MAST 4 underscore reverse code. MAST 6 underscore reverse code. And then MAST 7 underscore reverse code. Okay. And this one was only 1 to 4, right? It was 1 to 4. So what we do is we go to old and new values. So if it's a 1, it gets a 4. If it's a 2 in the original, it gets a 3. If it's a 3 in the original, it gets a 2. And then if it's a 4 in the original, it gets a 1. And you can always tell what's the importance of this reverse codal. Great question. Some scales, so when a person is, when a scientist is developing a scale, okay, what they will sometimes do is they will pose a question in the opposite of all the other questions, right? So whenever you're developing a scale, you generally want your high numbers or your low numbers to all represent positive or negative, right? So for example, if you're developing a survey, you want the high numbers to represent a positive attribute on your scales, right? So let me see. Are there questions on here? Do you smoke? No, I don't have the actual questionnaire, but I'll look and see. I'll try to find the actual questionnaire and then I'll show you. So essentially what it is that you want all of your questions to, the high questions to represent the same either positivity or the high questions to represent negativity. So if some of your questions represent positivity and negativity and others represent negativity, the ones that represent negativity have to be reverse coded so that the scores reflect the same characteristics. Because whenever you're developing a survey, you want your high scores to all represent positive character, the same disposition or characteristic of the phenomena, right? So generally, the low scores represent something negative and the high scores represent something positive. But sometimes you'll have some questions, the high scores are negative and you have to reverse code them so that all the scores that are positive are all have the same number. Does that make sense? Okay. Okay. Great. Great. That's a great question though. And that's part of what we do with psychometrics when we develop surveys, right? Because you may have heard something called Cronbach's alpha, right? And what Cronbach's alpha does is it looks at the internal consistency of the scores. And if a lot of your scores are high, questions have high scores, and then some of your questions have low scores, it may affect the internal consistency of the instrument. So that's why you have to make sure that the individual questions are correlated with one another. Okay. And you generally have that when they're all going in the same direction. High scores are positive, low scores are negative. All right. All right. So, and then you can also check too when you're doing this where it's ascending and descending. Okay. So I'm going to click paste. So this is going to be it should be reverse code. And this should be reverse code mastery 1, 3, 4, 6, and 7. And then we can see what it is here. We're going to highlight it and run it. And then we're going to do the check. So the check is going to be mastery 1, three, oops, 1, 3, 4, 6, and 7, and then mastery reverse 1, 3, 4, 6, and 7. So what I do to highlight this, I click on the first one, hold down the shift key, and then move it over, and then I click paste. Okay, so this is recode check number 2. Reverse code check. Reverse code check number 2. Let's get a blank slate. All right, so 1. So we got 1 equals 4, 2 equals 3, 3 equals 2, and 4 equals 1. Oh, we gotta do them one at a time. So what it did is it actually ran all of them. So let me just show you what I did. The reason why, and I'm trying to hurry because it's just past 9 o'clock. The reason why it did that is because I basically told SPSS, compare Mastery 1 to Mastery 1, Mastery 1 to Mastery 3, Mastery 1 to Mastery 4, Mastery 1 to Mastery 6, Mastery 1 to Mastery 7, Mastery 3 to Mastery 1, Mastery 3 to Mastery 3, Mastery 3 to 4, blah, 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 right? We don't want that. We have to do them one at a time. Okay? So we have to do them one at a time because otherwise it's going to run them all together. You see what I did? Does that make sense? You have to do them one to one. So mastery Q1 to mastery 1 reverse, right? Because otherwise it's going to run them all together. If you understand that, type in a 1. If you don't understand that, type in a 0, because what it did is it ran them all together. Okay. So then let's run this really quick. That's 3, 3, 4. All right, so we've got this. We got, oops. All right, so we've got 1 and 4, 2 and 3, 3 and 7, 4 and 2. Okay. All right, so then we're going to do the next one. So here, let me show you a little. Right, so we can just copy this. And then we just change the number 4 here. And run it. That's why syntax is so beautiful, because you can do it so quickly. So again, we've got 4 and 1, 4 and 2 and 3, 3 and 2, 4 and 1. All right. And then we've got 6 and 7. Yeah, 6 and 7. 6 and 7. Oops. They got to be the same because we don't need to mess that up. They have to be the same. 6 and 6, and then 7 and 7. Yep. They're all the same. Okay, that's good. And then we're going to do 7 and 7. Oops. 7 and 7. So this is the portion that you have to be very careful. That's why you do all this stuff in syntax, because you want to make sure that you did it right. You can always go back and look. Okay. Boom. All right. So that's good. All right. So we're going to save this. We're going to go to so mastery has been confirmed. Okay. All right. So we'll continue with perceived stress tomorrow, and then we will conclude with this section, and then we'll start preliminary analysis tomorrow as well. Okay. Now, preliminary analysis is when we start running descriptive statistics on our demographic data, and we start testing the assumptions of the statistical test. All right. So tomorrow will be day 4, and we will finish up the recodes, and then we will go into preliminary analysis. All right. So that works out fine because tomorrow is day 4. 4 and 5 are basically preliminary analysis, and 6 and 7 are primary analysis, where we actually run the specific tests. All right. Does anyone have any questions? Does anyone have any questions? If you have any questions, type in the queue. All right. So I have a question. I don't know. I'm going to send out an email because I have a lot of students in Europe who signed up for this class. So I'm thinking about doing the class twice a day. Once at 8 p.m. and then maybe either 10 a.m. or 12 noon. 12 noon, because then it's in the evening in the UK or in Europe. So I'm thinking about that. I'm going to send out a survey. So I just want you, when I send out that survey, I want you to tell me which times you prefer. Okay. If I was to have 2 times, well, actually 3, 10 a.m., 12 noon, and 8 p.m., I want you to let me know, just so that when I'm planning for the future, I know what times to use. Okay. All right. Again, thank you so much for your patience. It's 9:19. So I appreciate you hanging in there with me. Thank you so much. Hopefully this was helpful on a scale of clarity, on a scale of 1 to 5, where 1 is not at all clear and 5 is extremely clear. How would you rate this, what we did today? And remember, the people who have the videos, who purchase the replays, you have the replays for 12 months. So you can go back and take a look at it and go through all the process for your own data as well. And you can also ask me questions as well. All right. Thank you so much. I'll see you tomorrow at 8 p.m. Okay. Same time, same place, same bat channel. Thank you. Thank you. Thank you. Appreciate it. So I'll see you tomorrow at 8 p.m. And I'll be sending out that survey very quickly in about 30 minutes or so. And then I'll have the replay up as well in about probably about an hour or two. I'll send out the replay to everybody. Okay. Or to the people who pay for the replay. All right. Thank you so much. Thank you so much. Have a good evening.